Hi. So for lesson 5, what we would usually do in class is I would give you this PowerPoint for you to work through on the computer, and you would fill out the guided notes based off the PowerPoint. So usually you would have a piece of paper with the notes right there in front of you, and you would be filling in the blanks and solving things based on this. However, I can't give you the piece of paper to fill out and go through on your own independently. So what I'm going to do instead is I'm just going to kind of lecture at you through the PowerPoint, and you should take notes or pay attention. I'm going to add some questions at the end, although I haven't figured out what exactly that's going to be. If you did happen to print out the notes for lessons or for Unit 7, because I know some of you at home have been able to do that, the guided notes, you have this then in the packet and you can just go ahead and fill it out on your own as well. Okay, so how do electrons move between orbitals? So those of you that took chemistry, this might feel a little bit like review. Even if you took chemistry and you're like, I don't remember this at all, that's okay. We're going to learn it again. And if you didn't take chemistry, that's totally fine. That's why we're doing this, so that you can see how to do this. All right, so this is an atom. This is a hydrogen atom. We would call this the Bohr model of an atom because it has the orbitals on the outside. And yeah, so these are the orbitals, the little dotted lines. And each ground state is the one that's closest to the proton. So that first one, let's see if I can move my mouse. Yeah, this one right here, this is the ground orbital. Okay, so we would call that N1, just meaning orbital 1, orbital 2, orbital 3, orbital 4, or infinity, whatever. And then when the electron is ionized, that means that the electron has left the atom, and that sometimes happens. So N2 to infinity are called excited states, so that's when the electron jumps and it goes to an excited state. The one electron can be found at any level. So any electron can jump between any of the orbitals. It just depends what's going on with the atom and if it's in an excited state or not. Okay, the Bohr model for hydrogen. So one electron in hydrogen does not orbit or move around the nucleus. It exists in a state. Okay, so it's going to be what I mean by that is usually when we talk about the Bohr model, we think about orbitals, but it just exists in a state. That's because the more modern theories of atomic theory, we learned that electrons have a lot more behaviors than just existing in an orbital. Don't worry about that. We'll learn a little bit more about that later. The electron can only be found at discrete, certain specific allowed distances, which are unfortunately still called orbitals. So there are distinct areas where you're more likely going to find an electron, and that has to do with what we call the wave function of an electron, but don't worry about that. That gets to be into pretty high, like quantum physics stuff. So all you need to know is that there's discrete orbitals where these electrons exist. So each orbital has a quantum number, n. The orbital is the closest to the nucleus, and that's the ground state, and has n equals 1 because it's the ground state. It has the lowest energy, and in this case it's negative 13.6 electron volts, which you can see on page 2 of the reference table, which we'll get to in just a moment. So the orbital furthest from the nucleus has the highest energy, and that's n infinity, and the energy of that orbital is 0. In that case, the electron is said to be ionized, in which case it is completely removed from the atom. So every once in a while, an electron will just completely jump out of the atom, and it will create what's called an ion. And that happens when the electron becomes so excited, it just leaves. Okay, so these are the equation in the reference table, and we are going to be talking about mostly photons. So E photon, so that's the energy initial minus the energy final. So energy. So the photon emission, if an electron moves from a higher energy orbital to a lower one, the photon of light is emitted, given off. So when it jumps down, that means there's going to be a photon of light that is released, just like that in the animation. So a photon is emitted. That's because it's lost energy, it's emitted a photon, and usually this is some color or ultraviolet light. The energy of the emitted photon is going to be the energy initial minus the energy final, which is that equation in the reference table. So an example problem, find the energy emitted of an electron at N3 that transitions to N2 in a hydrogen atom. Following slides will show you how to do this. So also you should know our next focus is going to be on this. So I'll explain it here, but then again, when you learn how to do the focus, you're going to learn how to do it with that video as well. Okay, so this is actually page 3 of the reference table. We have a hydrogen atom. So if it jumps from N1 to N3, we are going to look at the levels. So N1 is in electron volts. And here we go. So it starts at N3 and it is going, and so the energy for 3, the initial energy is negative 1.51 electron volts. And it jumps down to energy 2, and so that gives us negative 3.4 electron volts. So then we're going to follow this equation, so E3 minus E2, and you'll notice it gets a little bit weird with the sign since it's subtracting a negative, so just put it in your calculator and it gives you the answer, and it's 1.89 electron volts. So the easy way to do this is you just ignore the negative signs and just subtract. That's one way you can do it. I don't want to get into all the math details for why that exists, but it just has to do with either it being absorbed or emitted. So that's how we do it. So that's the energy that is released when it jumps from the third orbital to the second orbital. Okay, so now we're going to take a look at electrons that jump. So this is when they absorb energy. And to do that, they will need to take energy from light. So in photon absorption, if an electron moves from a lower energy orbital to a higher one, a photon of light is absorbed or taken in. So in this case, it's going to go from N2, N3, and when it does it, it absorbs a photon. So I'm going to go back so you can see that animation again a little bit better. So here we go. It's going to absorb light, and then it jumps to a new one. So it absorbed the light. The energy of the absorbed photon is going to be whatever orbital it started in minus the energy of the orbital that it ended in. So here's like an example problem. And an electron in a hydrogen atom jumps from its ground state to its third energy level. How much energy is absorbed? So we're going to look back at this diagram. We're starting at the ground state, and that is negative 13.6 electron volts. It jumps to N3, which is the final, so N3 is negative 1.51 electron volts. We're going to take an E1 minus E3. You can ignore the negative signs for this, and you get 12.09. So that is how much energy has to be absorbed for it to jump from the ground state to the third, and only that amount of energy. If it was 12.1 or 12.08, it will not jump. It has to be exactly that amount of energy. All right, so energy conservation. The emission, or the birth of light, that's when the atom loses energy as an electron moves down. So a photon removes energy. Absorption is the death of light, meaning that the photon brings energy into the atom and the atom gains energy as the electron moves up. In both cases, energy gained equals energy loss. So again, conservation of energy, we can't just go around creating energy whenever we feel like it. It's either going to get added to the electron or released to the electron in the form of light. Okay, so these are some technical notes. So the technical term for jumps is transitions. There's no in-between jumps are allowed. Like you either jump from 1 to 2 or 1 to 3. There's no like 2.5, etc. It has to be an exact amount. So only jumps from one allowed energy level or orbit to another allowed energy level are allowed. That is why only certain energy photons can be emitted or absorbed by atoms. Since E photon equals HF, which we learned earlier in this unit, only certain frequencies or colors are produced. That is why photon energies are quantized. Only certain values are allowed. So there's only certain frequencies where this is allowed to happen. So that's why when you look at an electric spectrum, you will only see certain colors because other colors can't be emitted. Okay, so the change in the amount of energy equals the amount of jump. The bigger the jumps, the more the change of energy. The more energy photon, the higher the frequencies. So that's going to be like blue light, ultraviolet, violet. So if it's a big jump, that's the type of photon it's going to release, that color. Little jumps are less energy, so there's not as much energy in the photon, so it's going to have a lower frequency and is going to have like closer to red or infrared or even orange colors that are released. This is true for emission and absorption, so it'll either absorb a blue light or release a blue light depending on if it's jumping or absorbing. So we learned this in the last unit, in the wave unit, And if you ever need to look up what type of light is emitted or absorbed, you would look at the frequency in the diagram like we did for that one focus, and you would look down here and figure out if it's violet, blue, green, or if it's ultraviolet or infrared. Oh yeah, so high frequency means a big jump. It's going to be a blue, violet, or ultraviolet color, and if it's a low frequency, little jump, it's going to be more of like a red color. Okay, so summary of lessons. How do electrons move between orbitals? And so now that you've done that, you can go ahead and answer this stuff on the Google form. And yeah, moving right along. All right.